In our previous lesson video, we learned about examples on product identities, where we applied these four principles of sin P plus sin Q, sin P minus sin Q, cos P plus cos Q, and as well as cos P minus cos Q. But in the last lesson video, we learned from how to move from the sub expression to the product. Now, in this lesson video, we want to learn on how to move from the product to the sum. So we have two questions. The question says, express each of the following as sum of two trigonometric ratios, emphasis on the sum. And we have two questions, sine 5x cos 3x and cos 7x sine 5x. So let's begin with the first one, sine 5x cos 3x. Now, if we look at these four expressions, 1, 2, 3, and 4, we have to look for the one that tallies with sine and cos. So here it is sine cos, cos sine, cos cos, sine sine. And the other here is sine cos. So which one works? So that means we are saying that sine cos works. So we can copy this formula, duplicate it, just as we did in the previous video, and move on here. Now the question we're given is sine 5x, okay, cos 3x, sine 5x cos 3x. But in the formula, we have an expression of 2 here. So let's divide both sides by 2. Dividing both sides by 2, we will have this to give us sine P plus Q divided by 2, cos P minus Q divided by 2. And the left hand side will be sine P plus sine Q into 1 over 2. So now we can now make our correlation or comparison that this is sine 5x and the question of cos 3x. So with that, we'll understand vividly that P plus Q over 2 is equals to 5x and P plus Q over 2 is equals to 3x. And all we just have to look for is the expression of 1 over 2 sine P plus sine Q. So therefore, we are looking for P and Q. So let's rewrite. From here, we have that P plus Q divided by 2 is equals to 5x, and P minus Q divided by 2 is equals to 3x. So with this, we can simplify for P and Q. So we have P plus Q to be equals to 10x if we cross multiply, P minus Q to be equals to 6x. So therefore, let's bring them together so that we'll solve the two equations simultaneously. 10x and P minus Q is equals to 6x. So therefore, if you add these two expressions together, we will have that 2P is equals to 16x, and therefore P is equals to 8x. Now, if P is equals to 8x, from this expression, we can find the value of Q. So therefore, P minus Q is equals to 6x. So we are saying 6P, which is 8x, minus Q is equals to 6x. So therefore, Q will be equals to 8x minus 6x, and Q is equals to 2x. So we have Q to be equals to 2x and P to be equals to 8x. And what we are looking for is an expression of the sum. So the sum in this case is 1 over 2 sine P plus sine Q. So let's rewrite the formula that we have here. We have the 1 over 2 sine P, okay, plus sine Q is equals to sine P plus Q over 2 cos P minus Q over 2. So for more ease, let's move this to the right hand side so that we'll understand the concepts much better. So with this now, we have that P is equals to 8x and Q is equals to 2x. So therefore, we are saying that sine 5x, which is the question, sine 5x cos 3x is equals to 1 over 2. We make our substitution of P, where P is 5x, okay, where P is 8x rather, and Q is 2x sine 2x. So yes, we have solved the question number 1, and we have expressed it as sum of two sine expression of sine x, sine 8x, and sine 2x. Let's move on to the second question, where we have cos 7x sine 5x. Question number 2, cos 7x sine 5x. Now, in this case, we have the order of sine followed by cos, or cos followed by sine rather. So we have cos sine. If we come back to our formula, here we have sine cos, here we'll have cos sine, cos cos, sine sine, and we are looking for what? Cos sine. So we are going with the second. So let's duplicate, where we have sine p minus q, sine p minus sine q is equals to 2 cos p minus, duplicating it, we have sine p minus sine q is equals to 2 cos p plus q over 2 sine p minus q over 2. Now let's divide both sides by 2, and here we will have cos p plus q over 2 sine p minus q over 2 is equals to sine p minus sine q multiplied by 1 over 2. So with this now, we can find the values of p and q, because we understand that the question is cos 7x sine 5x. So we are saying in essence that p plus q is equals to 7x divided by 2, and p minus q divided by 2 is equals to 5x. So let's solve that. P plus q divided by 2 is equals to 7x. P minus q divided by 2 is equals to 5x. So in essence, p plus q is equals to 7x. P minus q is equals to 10x. So if we solve this simultaneously now, let's have p plus q, 7x, p minus q, 10x. Solving it simultaneously, let's add the two expressions together. So we have 2p, okay, this should be 14x rather. P plus q is 14x. Apologies about that. So when we excuse me, when we add these two expressions together, these two equations, we have 2p is equals to 24x. So with that, we have that p is equals to 12x. So from here, where p minus q is equals to 10x, okay, therefore 12x minus q is equals to 10x. We find an expression of q will be 12x minus 10x, therefore q is equals to what? 2x. So we have p is equals to 12x and q is equals to 2x. So we go back to our formula that we are looking for, that cos 7x sine 5x will be equals to 1 over 2 sine p minus sine q. Therefore, let's write it out again. That cos 7x sine 5x is equals to 1 over 2 multiplied by sine p minus sine q, and we have evaluated that p is equals to 12x and q is equals to 2x. So we have this to be equals to 1 over 2 sine 12x minus sine 2x, which we have expressed in terms of sums. So now we can see the interesting part. All we just have to do was to move from the product section down to the sum section. Now let's take an exercise on product identities.